Hello viewers, welcome back to our YouTube channel, and today we want to start our new chapter, which is chapter 4, methods of presentation of data in tables. So of course this study is going to be one of the topics that are going to kickstart our journey of computations as well as quantitative techniques paper is concerned. So by the end of this chapter, you should be able to construct various tables for different data set. You should as well be able to interpret the data that has been presented in those tables, and of course you'll be able to identify the advantages of each of the tables and then the limitations of each of the tables that are being used in order to present data. So we all know that statisticians are supposed to organize, explore, and then summarize data for easy interpretation. And this chapter shows how data can be presented in a tabular form for various purposes. So we are going to see how we can analyze data using tables. That is the main purpose for this course, for this chapter. So of course the data we are summarizing, it's the data that we collected using the data collection methods that we looked at. So after you have collected the data, that data should be organized and summarized in a meaningful way, because the data that we are going to collect, or the data that we have collected from the field, most of the times that data set may have very many entries, and it may be difficult for us to see the different patterns or the different attributes of that data, so that we can be able to make meaningful decisions out of the data that we have collected. So the most convincing and convenient method of organizing data is to, of course, put the data into what we call tables. And these tables, they could be frequency distribution tables, whereby the data is going to be organized by grouping the data into what we call intervals. And these intervals, they are the ones that we call classes. So we form the frequency distribution or the frequency distribution tables to be able to classify these data based on different intervals. So the number of times a particular distinct value occurs is what we call frequency, or the count. We count the number of times a particular value occurs. So that's what we call frequency. And frequency distribution is just the organization of raw data in what we call table form, using classes and frequencies. So After organizing the data, the researcher must present the data that they have organized. Of course, the way you present this data is you present it in a manner that can be understood by everyone, even those without statistical knowledge, so that the data can actually be able to give the reader the benefits. So the most useful method of presenting data is by constructing what we call tables or frequency distribution tables, or it could be constructing statistical charts and graphs. For example, we can construct things to do with histogram, we can construct things to do with frequency, polygon, all gives, pie charts, Pareto charts, Lorenzo curves, and time series graphs, and so many other things, as we shall look at. So the important characteristics to look for when you're organizing and describing a data set is to look at its center and its variability, as well as its shape. So the frequency distributions can be made for both data. It could be for qualitative or what we call the quantitative variables or data. So what we are going to focus on before we look at the tables themselves, and before we look at the principles of designing a better table for presenting the information, we need to understand that data, even if the data is qualitative in nature or it's quantitative in nature, we can still use frequency distributions or frequency distribution tables to make sure that we analyze this data very well. So we shall achieve that by looking at both aspects. We look at those that are qualitative in nature, then we also look at the ones that are quantitative in nature. So let's now understand the tables. Table or tables. Of course, a table refers to a layout. So a table is a layout of information, or data, in form of a table is a layout of data or information in form of columns and rows, columns and then rows. So as long as the data has been presented in rows and columns, then we say that that information has been laid out in a tabular format or in a tabular form. So these are the simplest form of data display, just within columns and rows. Some of the possible reasons for which tables may be constructed, of course, one of them, because someone may be asking, why do we actually present data in a tabular form? We construct these tables because we want to present the original figures in an orderly manner or form. We need to present the original figures in an orderly form or manner. The other point is that we want to show a distinct pattern in the figures. We want to show a distinct pattern in the figures. We want to show a distinct pattern in the figures. Of course, the third reason as why we organize the data into tables is because we want to summarize the figures. We want to summarize the figures for easy interpretation. For easy interpretation. Then lastly, we want to publish silent figures with other people, which other people may use in the future. We want to publish silent figures. We want to present silent figures which other people may use in the future. For statistical studies or in the future statistical studies, because this information, once we publish it, and you can't publish the information when it is disorganized. So when you publish it, other people can use it when they are carrying out their research as maybe what we call the secondary data. So we collect this information, we analyze it very well, and then we publish it, or we save it somewhere, maybe on internet or maybe in books, so that these other people can use them in their statistical studies that may carry out. So those are some of the reasons as why we use tables. But before that, we also need to before we look at the types of data and how we can organize the data into the forms, we need to understand the principles of table design. Principles of table design. These are like things that you are supposed to follow when you are designing tables so that we can be able to have data that can be analyzed clearly. So the principles to construct a table so that it achieves its objective in the best way possible, they include the following. One is simplicity. Some of the things I'm just going to explain them, then I write out points, then I explain as you pick out based on what you have understood. So for simplicity, a table with too much detail or which is too complex is hard to understand. So it is better to show only a little of the information that is understood than to show all the information having nothing understood by the recipient. So it is better for us when we are constructing these tables to make sure that we simplify by putting in a few kind of information that is going to be understood than having a lot of information that is not going to be understood by the respondents. The other is, of course, the comprehensive explanatory title. Comprehensive explanatory title. Explanatory title indicated above. Indicated above the body. Above the body of the table. Because we need to understand what is that table representing. That's why we always give them titles, and these titles, they should be easily understood by the respondents. The other is that the sources must be stated. That's why most of the times whenever you see a table, maybe in a book, they always put some words to explain where this information came from. You don't just put a table and you don't show where the table, where you got the information that you have displayed in the table. So you always state the source of the information. So all the figures must have come from somewhere. So that's why a statement of the sources must be indicated below the table, because we have picked some information from somewhere. The other is units of measurements must be clearly stated. Units of measurement must be clearly stated. Units of measurement must be clearly stated. Of course, say that the units of measurement must be clearly stated. For example, the currency. Most of the times you will find that they have put the information, maybe UJX, or in thousands. UJX in thousands, and it's always in the bracket, just to indicate that the currency in which they collected this information in is a Ugandan currency. It could be in terms of, maybe they were carrying out weights, and these weights maybe were in kilograms. They always indicate the unit of measurement for the data that they have collected. If they are ages, they always put years. Even if they say maybe from 10 to 13, they always put it in a bracket and they say years, to indicate that the unit of measurement for that data that was collected, these were years of different people that they have talked about in the question. So the unit of measurement is very important, even if you are talking about currency, because most of the times they always put the unit of measurement in the heading, whether they are in thousands, whether they are in US dollars, they always put those in the, maybe in the title or in the headings, so that they can be able to represent the unit of measurement in which the data is representing. Of course, even double counting. Double counting of figures. Double counting of figures should be avoided. The double counting of figures should be avoided because it creates misleading presentation. Because if you instead of maybe writing 2 million, then you end up writing 4 million, it means you are going to provide misleading information. Because you can write 2 million, the figure could have been 2 million, and for you wrote maybe 4 million, but in the total you give a figure which is below by 2 million, meaning somewhere you did some double counting and you didn't realize it. So that's why we are saying the double counting is just include counting the figures twice. So it should be avoided. Then the other one, since we have said that this data is going to be arranged in columns and rows, then the headings to columns, the headings to columns and rows, the heading to columns and rows, the heading to columns and rows should not be ambiguous. Should not be ambiguous. So you should be able to use short headings so that you can be able to remove the ambiguity. And those headings should actually be clear and understandable. So these are some of the things. Maybe we can talk about like 2. We'll finalize. Some of the things they may not ask you, but we are giving someone information, not necessarily for you to just pass the exam, but even those who are in, maybe they are studying this, but they are just doing it maybe in practical. They cut out some of the things that we are talking about. So figures, the figures should be approximated before tabulation to reduce the unnecessary details in the table. So the figures should be approximated before tabulation. Approximated before tabulation to reduce the unnecessary details. Things to do with decimal points. If maybe you have computed figures and they are maybe 4.57633, you can round these figures off. You can either take 5 or you can take a 4.6, so that you don't have unnecessary details that are not yielding anything or that are not adding value. Because the moment you provide too much information in the table, you are going to make the viewers not to understand the information. Of course, lastly, we can talk about maybe arrangement of data in the table can be on a chronological order or an alphabetical order or according to the magnitude to facilitate comparison. So arrangement arrangement of data in a table may be arrangement of data in a table may be on chronological order, may be on a chronological order, or alphabetical order, or it could be according to magnitude. When you talk about magnitude, we mean the size. Magnitude to facilitate comparison. Now, what we are meaning here is that when you are giving out information, it's always good to give it in a certain order. Maybe you start with the smallest down to the highest, or from the highest down to the smallest. But most of the times they always give smallest down to the biggest. That is the ascending order. So if you are giving the years of students, maybe you start from 0 to 10. That's maybe one class. Then from maybe 10 to 20. And you also indicate its frequency. Maybe from 0 to 10, maybe the frequency, or there were 10 people, these were maybe 3. So this one creates a mechanism of how you can compare the information. You compare that the people who were aged between 0 to 10, there were 10 people. Those who were 10 to 20 years old, there were 3. So it creates the kind of mechanism for the respondent to be able to compare the information even before you do any mathematical computation. So those are some of the principles that you need to understand as you are providing tables. Then maybe last thing that I need to talk about is for the totals. Remember we said we have columns and rows. So the totals should be shown where applicable. Maybe you have given the total frequency, or you have not given. But as long as it's necessary, you indicate the total columns. So they are going to be used in the table for one of the following purposes. Of course, someone can know that the overall total, maybe the overall total frequency was this, or the overall students were this. If you give the total, it also indicates that the preceding values are just maybe subdivision of the total, because you can have subtotals, then you have the grand total. So if it is necessary, then indicate the totals. And the other one, it also indicates all the items that have been accounted for. So that's all that we have to do with tables. Now, I just want us to understand what are some of the tables that we are going to use when we are presenting data. So I want us to look at the types of tables that we always use when we are interpreting data. They are not always many. They are like 2. The types of tables. So want to look at the types of tables. Types of tables. Types of tables. Of course, I've already talked about the frequency tables. So let's start with what we call they are called univariate tables. What are univariate tables? Of course, these univariate tables, they are just tables that are used to describe the attribute of only one variable. These are tables. These are tables. These are tables used to describe. These are tables used to describe the attributes or the characteristic of one variable. They are used to describe the characteristic of one variable. Variable is like one kind of item that we talk about. So what could be an example of we can maybe have we can look at the different papers, papers offered by the Institute of Certified Public Accountants of Uganda, by the Institute or by ISPAU, Institute of Certified Public Accountants of Uganda. So you see that we are looking at only one variable. So the one variable that we are looking at are the papers that are offered by the institute. So how are we going to display this information? It is very easy. We use what we call a univariate table. So it will, you just draw a paper, then you put of course you put a heading. Of course, we said we represent them in rows and columns. So since it is just one variable, and variables, the variables are always represented in the columns, then the rows represent the items. That's as per the statistical softwares like SPSS and Stata. So we can have the paper offered. Or we can just have one heading, papers. You don't need to write papers offered by the Institute of Certification. That will be a very wrong table. You can have it like that. Then we start putting in the papers. Of course, we have what we call the financial accounting. We have the financial accounting. We have, let's put the quantitative techniques, this same paper we are studying. Quantitative techniques. Quantitative techniques. We can put maybe financial reporting. Then we can put financial management. Financial management. You can also add taxation. You can also add advanced taxation. But even if we just stop there and we close our table, remember the principles that we talked about. The big question is that where did you get this information from? So we need to show the source of where we got the information. And we said the source is always at the bottom of the table. So we close our table like that, then we put the source. Most of the times they write the source using italic. If you have been observant, they italicize the source. So it is the source. Of course, we have got it from the Institute of Certified Public Accountants. I can use ISPAW. Permit me to use ISPAW. If you have got this information from the website, you just put the website where you have got this information. ISPAW, Institute of Certified Public Accountants of Uganda. And that's it. It means from there you have presented it well. It has a title. It is portrayed in rows and columns. Then it is also having the source of where we have got the information. So as long as you are representing only one variable, you use what we call the univariate. But now, what happens is that most of the information that we are going to be getting is not all about one variable. Maybe we have studied so many variables. So, if we have very many variables, which type do we use? So, the second type, part B, we have what we call the frequency tables. Frequency tables. Frequency tables. Frequency tables. Of course, this is the main table that we use. Now, for frequency tables, of course, I explained that frequency tables they are just tables that represent more than one variables. It could actually be a one variable, but this variable has been repeated very many times or more than once. We could be talking about the age of maybe the students, but we are giving, there are very many people who are aged maybe 10. So we end up having very many people in a certain category. So here, the best definition we can say, it is the table where cases, it's a table where cases of one variable where cases of one variable appears more than one times. And we we do this into what we call the frequency distribution. Frequency distribution. Those tables are called frequency distribution tables. They are called frequency distribution tables. So the frequency distribution tables, they are the ones that we are going to use. Frequency distribution tables are used. So these tables show the item or the items and the number of times each item appears. So you are going to have two columns where you are going to have the item and then you show the frequency. And the frequency represents the number of times that item appeared. So a frequency distribution table can be constructed running horizontally or they can be vertically. So we can draw them like vertical like this. Maybe if we are looking at, rice, it appeared 20 times, maybe maize, maybe 10 times. So this is a vertical representation. But if it is going in a horizontal way, it means we shall have the item and then we have the frequency going like this. Then we put the item, maybe it is maize, we put the frequency, let's say 20. We also put the other one. So this is a horizontal, then this is a vertical aspect. So either way, that's how we represent that information in those frequency distribution. We said a frequency distribution is just an organization of raw data into a table form using classes and frequency. So what we are going to use here are classes and frequencies. So, but remember we said earlier on that this information can actually be presented for both qualitative and quantitative data or quantitative data set. So we want to first look at how can we organize or how can we present qualitative data in a frequency distribution. So we are going to drop the other univariate table and we just focus on the frequency distribution because that's what we use. Since we are going to be dealing with that data that is going to be classified using classes and frequencies. So we need to understand how do we present the qualitative data. Of course, we say that this is more of category names. So we need to understand, maybe we just look at one example, then we'll be able to understand. So, of course, organizing the qualitative data, we organize them into what we call the categorical frequency distributions. Frequency distribution. I'm just going to be writing distributions like that. So we use what we call categorical frequency distribution for the data that is quantitative. So what we do, we place specific categories such as the nominal. You remember the levels of data measurement. So in this, we are going to find what we call the nominal and ordinal level of data. These are the ones that we are going to be finding here. For example, we shall have maybe information regarding the political affiliations, religious affiliations, maybe major field of study, where we use the categorical frequency distributions. And this is mainly for the qualitative data. So let's look at maybe our first example to deal with. Maybe we first look at the blood test or blood samples or the blood type, because we said that blood type, they have what we call they are categorical in nature. So let's look at the example. We start with the 25 army induces. Let's use the army recruits. 25 new army new recruits. New recruits were given a blood test. To determine their blood type. And the following data set was recorded. The following data set was recorded. So let's look at the data. Let me write the data. We have the blood group A, blood group O, we have blood group B, we have blood group A, and then finally blood group AB. So they are just in columns. Then this one is B, O, B, O, then A. Then the other one is B, B, O, O, O. Then the other one is AB, AB, then A, O, B. Then the last one is O, B, O, A, B, then lastly A. And the question is, construct a frequency distribution for the data. Construct a frequency distribution for the data. Hope you have copied the data. You are saying construct a frequency distribution for the data. So if you have not copied the question, just pause the video and then you'll be able to copy. So solution. Of course, since this data is categorical, then we can use what we call the discrete classes. Of course, remember what we talked about, the discrete variables, that those are the ones that assume specific variables. So we are going to call these specific blood groups as discrete classes. If I talk about blood group A, that is a discrete class. Blood group O, that is a discrete class. Blood group A, that is a discrete class. Blood group AB, that's also a discrete class. So we are going to use the discrete classes for all the 4 blood types. Blood group A, blood group B, blood group O, and finally blood group AB. So these types will be used as classes for the distribution. Remember, we said that the frequency distributions, they are always classified in classes and frequencies. So the table has classes and then frequencies, but the classes that we are going to have are going to be discrete classes for the different 4 blood types or blood groups. And those are the ones that are going to form our classes for the frequency distribution that we are going to construct. So the procedure for constructing a frequency distribution for a qualitative data. If you are looking at qualitative data, the first procedure, of course, is to, make a table. Make a table. So let's do that. Whichever step that we talk about is what we do. Or we can talk about all the steps and then we do them. Of course, the second step is to tally the groups. You tally the data and press the results of the tallies and place the results in one of the columns, because remember we said the table is going to have rows and columns. Then when you are done with that step of tallying, the third step is for us to count. We count the tallies and we press the results in the next column. We place the results in the next column or column. So let's now look at the table. We draw our table, then we put in the information. So you make a table, you tally the data, and you place the tallies in one of the tables. Then the last step is you count the tallies and then place the results in the next column. So let's have the table. Remember, the table has to have columns and rows. So this is the first one. This is for the tallies, and then the other last one. Of course, here we have classes. Then we have the tally. Then we have the frequency. We close our table. Now, we have the blood groups. We said there were only 4 blood groups. You have blood group A, blood group B, blood group O, and then blood group AB. Those are we close the table because those are the only variables, groups that we have. Then we go on the side of tallying. Of course, you have to make the one for tallies to be a little bit bigger compared to others, because for the tallying you have to be tallying those items. Now you can see, if you check out the question, maybe if we scroll through the questions and we look for class A, this is how we do the tallying. You just come to, we are looking at blood group A. This is 1, this is 2, this is 3, this is 4, this is 5. There are 5 blood group A. 1, 2, 3, 4, 5. It's always good for you to use a pencil, then you cross so that you don't skip. So we have seen there are 5. So we go and put our tallies. I'm just going to show you one, then the rest you will do by yourself. Of course, when you come to B, let me also cross the one for B. This is 1, this is 2, this is 3, this is 4, this is 5. Of course, this is 6, this is 7. So you will do the rest for the other variables. So we go into the tables. We said when we tallied the one for A, we had 1, there were 5. So 1, 2, 3, 4, then 5. That's when you count 1, 2, 3, 4, even that the one cutting across is 5. So you put a 5 here. Then for B, we said there were 7. Maybe you can use a different color. 1, 2, 3, 4, 5. Then 1, 2. These are 2, these are 5, those are 7. You put a 7. Then you go to blood group O. Blood group O, there were 9. So you can also cross. You put the tallies 1, 2, 3, 4, 5, 6, 7, 8, 9, because there were 9. Then AB. For the last one, there were only 4. There were only 4 that were in blood group A, AB. 1, 2, 3, 4. You put a 4. Now the big question for you to do, to do right now, is to add up the total frequency. Remember, they told us there were 25 army new recruits. New army recruits were 25. So you add, are these people actually giving you 25? Of course, you get this 5 plus 7 that is a 12, plus 12 plus 9, that will give you a 21. 21 plus 4 gives you 25. So you are seeing the total frequency is what? Is 25. And they told us there were 25 people. So it means we have done the right thing. So that's how we present the frequency, the categorical frequency. Now, someone may ask you from this, which one is the most preferred blood group? Or how many people with the highest blood group? Of course, you pick out the frequency. So the one with the highest frequency, which is, of course, this one, which is a 9, is going to be blood group O, is the one that has very many people, because most of the new recruits have a blood group O, followed by those with the blood group B, because there were 7. So if you are looking at mode, the mode would be blood group O, because the mode will always pick out the one with the highest frequency. The model class will be blood group O. So these are some of the things that we can do for the qualitative data. Now, I want to give you like an assignment for, if I have 2 variables and all of them are categorical, maybe I have sex or gender, in other words, I have male and female, and at the same time maybe I have education. How am I going to categorize that data? I have the information I have information that relates to gender or sex, meaning I have female and then the male. Then I have education. Let me just call it education. And within the education, I have also different sections. Maybe I have the one for primary, secondary, and then the tertiary. But all this information is relating to male and female. So the same way you are seeing me representing it, that's how you will also present that information. So here, if I have primary, if I have here primary, this is primary, this is maybe secondary, then this is tertiary. Of course, I can have, now I can start to have the information for the male and then the female. Of course, here I can decide maybe to have 10, this is 20, this is 30, this is maybe 60, this is 25, 40. Then here I can have the totals if the information is presented in that manner. Of course, here we'll have a 30, this one will have a 55, then this one will have an 100. You can also have the totals this side, whereby you are having the column 4. So the table will actually look like that. That's how the table will actually look like. So I hope you have been able to get, these could be levels of education. Level of education. So that's actually this one is what we call, there are two variables. Of course, we have the sex and we also have the level of education, but they are all categorical data. And this one is not called a categorical frequency distribution. This is what we call the contingence table. This is a 2 by 2 table to summarize the information. This is just to summarize the information, to organize the information, or to present some information. This is just basic statistics. But that's how we can present the data that is related to qualitative. So we need now to look at how can we categorize data that is in quantitative format. We are not going to be looking at things that are categorical, especially for a CPA level student. But I'm just creating a background for you to understand where we are heading. We are going to be focusing on information that is quantitative in nature, because we are going to be doing some mathematical computations. Just like if you look at this, it will be hard for us to start computing, because these are, if you look at all this information here, these are not numbers. Even though these are numbers, we can get the total frequencies, but we can't do some computations here. We can't compute the mean. How will you compute a mean for a blood group A? Remember, for the mean is summation fx over summation f, as long as you have frequency. We have the total frequency, but we can't get the values. These values are not figures, because it will be A times 5, B times 7. Then you add them. There is no way you are going to add 5A plus 7B and you get a figure. So that's why we are saying some of the things that are capable here, those are the things that we are talking about when we are giving the levels of data measurement. And we are saying that for categorical data, the only thing that we can do, maybe we can do the mode, because mode, we just look at the frequency, what has appeared several times. Now with the model class here, we can take blood group O, but we can't compute the mean. We can also compute the median. We get the number that is in the middle. Of course, you know, for the median, we just use the frequency. This frequency will actually be enough. So we just take this frequency over 2 and we get the number that might be in the middle, or we get that class, the median class. So these are some of, we are limited. Not all mathematical computations are going to be handled here. That's why for qualitative, we all go ahead to do all kind of mathematical computations, because even those numbers can be expressed whether in decimals, whether in fractions. We can be able to do anything. So what we are going to look at now is focusing on what we call the quantitative aspects. And I hope you can see that we are moving. So let's look at and I'm taking it very slow, and I'm starting from the very basic statistical concepts, so that you can be able to pick the information. So presentation of the quantitative quantitative data. We said that when we are presenting, we use what we call frequency distributions. Now, here we divide the frequency distributions. We can have what we call the ungrouped frequency distributions, whereby the classes are not grouped. So we can have what we call the ungrouped frequency distributions. Ungrouped frequency distributions. Ungrouped frequency distributions. Ungrouped frequency distributions, and then what we call the grouped frequency distributions. The second one is what we call the grouped frequency distributions. I said you permit me, I'll be using this. Instead of writing the whole word of distribution, we write it that way. So we need now to know the difference between the ungrouped frequency distributions and then the grouped frequency distributions. This is only applicable when we are dealing with quantitative data. The ungrouped frequency distributions, it is mostly used for grouping quantitative data. Now, each class represents a single possible value. For this ungrouped, each class is represented by a single possible value. Maybe we can be dealing with years of students, and maybe we are just giving normal years. We are just saying 20, 30, 25, and you find that there are very many people who are aged 20 years. Instead of us grouping this data into interval classes, we just take each variable to be a class. We can take a class of 20, then we take a class of 30, a class of 25. That's what we call the ungrouped frequency distributions. We are going to look at an example. So, these particular possible values, they are the ones that we are going to form into what we call classes. But we only do this if the numbers, the distinct numbers, are small. We are dealing with small samples. Maybe if we are dealing with 50, maybe a sample of 50 people, a sample of, let's say, 20 people. So we can go ahead to do this, the ungrouped. So let's look at the example to provide us an understanding with the ungrouped. And I don't want to make this paper theoretical, because it is a computational paper. That's why you are seeing me every time I'm bringing in an example. You can say the data below. The data below shows the television ownership, TV ownership, ownership in 50 randomly selected households in Entebbe. Full stop. Organize the data into a frequency distribution and get its relative frequency. Of course, let's now give the numbers and then we proceed. So the numbers are also going to be arranged that's 1, this is a 3, this is a 3, this is a 0 and a 3. This is 1, 2, 1, 3 and a 2. Then this is a 1, 1, 1, 1, 1. This is a 2, this is a 5, this is 4, this is 2, 2. This is a 6, this is 2, 3, 1, 1. Of course, this is a 3, 1, 2, 2, 1. Then this is a 3, 3, 2, 3, 3. Then 4, 6, 2, 1, 1. This is 2, 2, 2, 1, 5. And finally we have 4, 2, 3, 3, 1. Of course, they told us they are 50. So if you want to count very fast, you can say this is 1, 2, 3, 4, 5. There are how many lines? This is 5 by what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a 5 times 10, that is a 50. So that's when you know that the information is actually enough. So we need now to create the solution. So we get the solution. Of course, this is ungrouped frequency distribution. So we are going to create what we call the ungrouped frequency classes and then the frequency columns. We repeat the same methods. We make a table, we tally, we do the tallying, then we put a column for tallies, then we put a column for frequency. But this question told us to calculate the relative frequency. Relative frequency is you just get that individual frequency over the total frequency times 100. That one I will not do, but at least you have gotten the formula. So the first thing that we need to get are the classes. Of course, we have the classes here. We have the tally. We said we make the tally a little bit bigger. then we put the frequency. Frequency we can make it short like that, but they also told us to get the relative frequency. Maybe you can put that relative frequency there. Then we complete our table. We are done with the table. So the table is done. What is left is for us to go, since this is, of course we have to let's first put in the classes before we move. Since these are ungrouped classes, so we are going to take the distinctive values of the data in the table to be our classes. And the numbers that we have numbers from 1 up to 6. Because if you look at the data set, they gave us numbers from 0 to 6. So 0, 1, 2, 3, 4, 5, and then lastly 6. Those are the numbers that we have. So the next thing that we need to do is tally. We go and cross those values, we tally, and then we get the frequency. But they told us that the total frequency here, the total frequency is going to be 50 because there were 50 people. The total frequency here, we can call it summation F. That is the total frequency is equal to 50. That one we already know from, sometimes they give it to you, sometimes they don't give it to you. And we've said that relative frequency, let me just call it RF, will be the frequency over the total frequency. Total frequency, which is the 50 times 100. This is the formula that we are going to use to fill this last table. So what I'm more interested in is for us to get the information to fill in the table. So this is the total frequency, or you can call it the total number of observations, the one that we have put below, to get those figures as they needed them. So we go into the table, we start looking for 0. Our class, the first class is 0. How many zeros are we having? We have only 1 0. Then we cross for 1. If you look at 1, we have this is a 1, this is a 1, this is a 1, this is a 1, this one, 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 and this one. So we count how many ones are we having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 ones that we have. If we go to 2, how many 2s are we having? This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The 2s that we have here, they are 14. If you go to 3, if you look at the 3, let me change another color. If you check for 3, we have this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. And this one is 13. So you have seen the reason as why we keep cancelling these numbers, because there are some times where we can skip some of the values if we don't cancel them. That's why I'm telling you, you get a pencil or a different pen, then you start crossing them as the way you've seen me crossing them. We go to 4. When you go to 4, of course, for the 4, you check this column, this column, this column, this column. This one is 1. And in this column, we don't have, this one is 2, this one is 3. There are 3 4s that we have. Then we go to the 5th. Of course, this one doesn't have this one, this one is a 1. Of course, now we come here and we pick, this one is a 1. This one we don't have, this one we don't have, this one is a 2. We only have two 5s. Even the 6th, we only have this and this. They are 2. So we go and take that information. We take the tallies plus their frequencies. So of course this one we saw only 1. So this one was 1, meaning even the frequency is going to be 1. For the 1, we had the 16. 1, 2, 3, 4. That is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is 15, 16. Because these were 16. Then for this one, the 2 were 14. These ones were 14. 1, 2, 3, 4. That is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are 14. Then for the 3, we had, there were 12 3s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those are 12. For the 4s, we had only 3 4s. 1, 2, 3. These are 3. For the 5, we had only 2. 1, 2. These are 2. Then we proceed for the 6th. The 6, we had, the class 6, we had only 2 as well. So they were all also 2. When you add these totals, this 2 plus 2, that's 4 plus 3, that is 7, plus 12, that is 19. So they are 19. When you add a 1, that becomes 20. So these ones are 20. The whole of these ones are 20. Now of course this one, 16 plus 14, that is 30. 30 plus 20 becomes 50. So we see that what we have got was right. That is the total frequency that we had written there earlier. And that was also given in the question. So we divide this to get the relative frequency. We divide 1 divided by 50. 1 by 50, you put the answer here. It will be 0.02. Then you get 16 over 50, because it is the frequency of that class divided by the total frequency or the total observation. So this is 0.32. This one is 0.28. This one is 0.24. This is 0.06. This is 0.04. And even this one is 0.04. When you add all this, it has to give you a 1.00. If you add all these, because the last one has to be 50 over 50, which is a 1. That's why we are saying that the total has to be 1. So that's what they wanted us to do. That's all that they wanted us to do. So this distribution gives us the useful information about the ownership of television sets in the Entebbe. Now, the question, of course, is going to be, how can I interpret this data? Of course, we will see that very few households were recorded to have more than maybe 3 television sets. There were very few. It is only those who had nothing. It was only one person. Those who had more than 3 television sets were only this and this. They were lying within here. So majority of the people are lying between 1 and 3. But the highest, the interpretation here is that one person, at least one person had what? Had a television. Because these were television sets, this data was belonging to television sets. So one TV, the person who had maybe one TV were 16. Those who had 2 television sets were 14. And those who had maybe 3 television sets were 12. So that's why we are saying that the ones that were having more than 3 television sets, we had very few people, because the ones that had more than 3 television sets from here, there were only 1, 2, and 3 people. Those who had 4 television sets were 3, and those who had 5 television sets were 2, and even those who had 6 were 2. That is the interpretation of the data. But if they had given to you the data as we collected it in here, as you are seeing these numbers, you can't make an analysis with this kind of data set here. But after putting that data set into a table, you can be able to make decisions about the data that you have. So whatever you have had, or whatever we have discussed, was in relation to what we call the ungrouped frequency distributions. Now, I want us to look at what we call the grouped frequency distributions. Grouped frequency distributions. But before we look at the grouped frequency distributions, one thing I want you to appreciate is the fact that this quantitative data can be expressed vertically and then horizontally. You have seen all this data has been expressed vertically, but we can also have this information expressed in a horizontal form, so that when you get information that is expressed in a horizontal form, you don't get worried. So we can have maybe just a small example to illustrate the horizontal display, just to get ourselves on the right track. We can have maybe number of hours. These hours can be in shillings. Let's write it like that. Then we have the number of frequency. We could have the number of frequency or we can call it number of tutors. If let's say we are looking at tutors who are teaching on an hourly basis. So this is the horizontal. We can put like 4 items. Now, we can say that those tutors who will earn an hourly rate of 8,000, let's assume they are 5 people. Of course, the number of tutors becomes the frequency. Those who are earning 12,000 per hour, we can assume that they are 10 people. Those who are earning 15,000 per hour, maybe they are 8 people. Then those who are earning 20,000 per hour, they are 2 tutors. So this is a horizontal expression. So instead of getting the total frequencies will be now added from this point. This is where we shall get the total frequencies. You add 5 times plus 10, that is 15. Then 15 plus the 10, that becomes 25. That is the total frequency. Of course, this is quantitative in nature. So we can do any mathematical computation. We can even get the mean. What is the mean pay? Or on average, how much can each tutor, or on average, how much are we paying the tutors? Whereby you find yourself getting summation fx over summation f. Of course, these ones we have already gotten as 25. Then the rest you multiply this one times this, plus this times this, plus this times this, plus this times this. The summation, the sum you get, you divide it by 25, and that will be the average rate in shillings that each tutor, or on average, we are paying each tutor. So I just don't want to rush myself on computations, but I want you to get where these things are actually coming from. Even the data itself can also be arranged in horizontal aspects. They can give you the data set like this: 2, 3, 4, 5, 6, 10, 20, like that. Sometimes they may not even put commas. They just say 2, 3, 4, 5, 6, 10, 20. So you have to get used on whichever way the examiner brings the questions. So we are getting some of these things from the very basic point of view, and then we can be able to interpret. So we are now going to look at what we call the grouped frequency distribution. And of course, when we are looking at group frequency distribution, maybe to just give us ourselves a hint on what we are going to talk about, is that when we are dealing with group frequency distributions, we are going to be dealing with what we call classified frequency distributions. Why? Because we are going to introduce in what we call classes. We are going to introduce in what we call classes. where we shall have information regarding certain classes, whereby we are going to have a table. We can have a table, and maybe we have these are classes, and maybe here we have the frequency. Then we just have a class maybe from 30 to 34, then 34 to 35, or 34 to 40. Then we put frequencies, maybe 2 or 3, and we proceed. So those are the grouped frequency distributions. The grouped frequency distributions, they are going to be in this kind of line, and we are going to be using what we call the classified frequency distributions. But at some point, we also have what we call the two-way contingency tables. When we are dealing with quantitative, remember we dealt with a contingency table when we are dealing with non-qualitative data. But even here, we can have maybe a qualitative aspect and then a quantitative variable. When we have two variables, but one of them is quantitative and the other is qualitative, where we use what we call the contingency table, where it will be a two-way classification. Let's look at a contingency. Maybe we also add in the contingency table. This can be, of course, we can have maybe the industry, then establishments. Of course, we find that this data is going to be divided. Maybe you can put the industry down here. Industry. Maybe within here we have different years. Establishments. Maybe this is 2020, maybe this is 2021, 2022. Such distributions. Then under the, of course, under the industries, we can have maybe health. Then we can have maybe agriculture. Then we can also have education. Of course, here we can have values. Maybe this is 20 or 20,000. Maybe this is 10,000. Maybe this is 30,000. We look at what we have established. Maybe this is 20. Maybe this is 10. Maybe this is 30. Data can look like that. Of course, we can add in maybe some other industry. We can also add in education. And maybe education had 80. This is maybe 75. This is maybe 50. Of course, we can close off the table. But remember, I told you, the moment you create a table, you have to show the source of the information. So you can come here, maybe you put, we got this, the source. Maybe we got this information from UBOS, Uganda Bureau of Statistics. So this can be what we call a contingency table. So that can be the contingency table for the qualitative data. Of course, you have also to understand that within this information, we always need to have advantages or to display advantages and disadvantages. So those ones you can know the advantages of using a table. Of course, it can help us to analyze figures more quickly. It is even easy to prepare. It reveals even pattern within which the figures cannot be seen if they are left in a narrative form. So you can create a pattern. It also enables required figures to be located. So those are some of the advantages. Then the disadvantages of course of using tables, we might have things to do with facts being double represented. Figures may be double represented for continuous data. And even interpretation may be difficult, especially where big figures have been reduced. Because remember, you are using a table. If I'm writing a trillion, I can't put all the zeros within the table, so I have to reduce. So when you reduce and some don't follow the units, they may misinterpret the information. Then the other one, of course, it involves computations. Whenever it has some computations, people who are not good at mathematics, they may lose out. So it involves some tedious mathematical computations, maybe getting totals. If the numbers are very many, people may get stuck. So for the group, that's for the group T frequency distribution. Group T frequency distributions. So we said when a range of data is large, the data must be grouped into what we call classes. And most of the times when we are carrying out the grouping, you have to understand that the figures within the width, we should put more than one figures in a width. If let's say within the data, I've got 20 to 30 as the class, it will be very hard for you to group such a class if maybe the frequency is just 1 or 0. This one will not be making any sense. You rather not have this class and you start maybe from 30 to maybe 35. So it is better for each class, at least you are distributing, you are creating. Make sure that at least it has more than one class. Because if it has a 0, then unless you have been told which class width to use, then you find yourself some of the classes have 0. But having a class with a 0 is really not a good way of presenting the data. So if you do that, when the class, you group a class and each class has more than one unit in width, that's what we call the group T frequency distribution, where each class shows the number of values that lie in it and its frequency. Because the people that may be falling maybe in the age of 20 to 30 may be like 10 if you are maybe examining a given number of students. But of course, we have looked at how we can categorize some of this data, but we need to understand their basic terminologies. Once I'm done with these terminologies, then we shall go ahead to look at other things. But I need to explain the terminologies, because the rest are going to be very easy. What will be hard are the terminologies. We need to understand the terminologies. So the first terminology within the grouped frequency distribution, we have what we call, because remember the data is going to be grouped into classes, and these classes have frequencies. So let's first start analyzing what are some of the classes that we are going to be formulating. Part A, we have what we call inclusive classes. What are they? Inclusive classes. Inclusive classes, or an inclusive class, this is where both the lower class limit, and the upper class limit. This is where the lower class limit and the upper class limit of a given class are included in the class. This is where both the lower class limit and the upper class limit of a given class are included in the class. It is particularly useful when the data are expressed in what we call whole numbers. And of course, there are very many distinct values that are going to be part of a single grouping. So this is mainly used for discrete data. For example, let me give you a class that has inclusive classes. Let me just create something small. If let's say this, let's just assume these are investments, and maybe we have days of maturity. Days of maturity. Of course, days of maturity, that will be our frequency, but I just want to create something small. This, let's assume this is a class of 30 to 39. Maybe this one is 4. Then another class is 40 to 49. Then maybe we can conclude with, maybe this is 2. Maybe you can conclude with 50 to 59. Maybe this is 7. And that's our class that we have. That's our grouped frequency distribution. Now, in this kind of distribution, the 30 we have here, the 30 that we have here, and the 39, these two values all belong in that class of 30 to 39. They all belong in that class. And this applies to all other classes, that even this 40 and the 49, they are all inclusive within this class. They are inclusive. So that's what we call the inclusive classes. But I want us to talk about the exclusive classes so that you can be able to see the difference. Let's talk about the exclusive classes. Exclusive classes. Of course, when we come to exclusive classes, this happens where the upper class limit, of a given class or a given classes, we can call them classes, of a given classes are excluded and included in the next class. Are excluded where the upper class limit of a given classes are excluded and included in the next classes. So each class consists of a range of values. Now, the smallest value that could go in a class is what we call the lower class, or the lower class limit. Let me write a class here. If I've said 30 to 34, this is our lower class limit. This is the upper class limit. Now, what this definition for exclusive class is saying, it says that the upper class limit is excluded from that class, but it is included in the next class. How is it going to happen? It's going to be, now the next class will start with 34 maybe to 40. Let me say 44. The implication is that in this class 1, if this is the first class, this one is 1, this is 2. This upper limit of 34 is not included in this first class, but it is included in this second class. Because the class is 30 to 34, then the next class starts with 34 to 44. It means this 34 here in the first class, it is not inclusive there. So if you are to write them as using these greater than or less than signs, this class will actually be a 30 less than 34, meaning the 34 is not inclusive. And this one will actually be 34 less than 44. Meaning this 44 is not inclusive in this class, but it is included in the next class. So they are meaning that These upper limits of each of these different classes are not included in those classes, but they are excluded in these classes, but they are included in the next classes. That is the implication. And we've said that this 30 is actually our lowest class limit because it is the smallest value that could go in a class. But now, the other smallest value that could go in the next class is what we call the upper class, the upper class limit. You see, this is the smallest value that goes into this class of 30 to 34. This 30 is the smallest class that could go, is the smallest value that could go in this class. But this 34, it is the highest in this class. But when you come to this class, second class of 34 to 44, it is the smallest class that could go in the next class. So it is the smallest that could go in the next class. Because if you come to this next class, it will be the smallest. Even though in the first class it was the biggest. So you can explain it interchangeably. So this, you can say, it is the smallest class of the next class. But that won't make any sense. That's why we are saying that it is the smallest value that goes into a class. That is the lower class limit. But the smallest value that could go in the next class becomes our upper class limit of the previous class. Because this side it is the upper class limit, but when it comes to the second class, becomes the lower class limit. And then the cycle continues. So you have to note that the lower class limit of a class is the same as its lower limit. So when we say lower class limit and then we say lower limit, they mean the same thing. The upper class limit of a class is the same as the lower limit of the next higher class. So this method is particularly useful when data is continuous. So you have seen, when you are looking at continuous data, we use what we call exclusive classes. But when we are using discrete data, we use what we call inclusive classes. And that's the reason as why we spent much time understanding what is discrete data and what is continuous data. And we gave so many examples to analyze that because we knew we are going to be using that information. Now, the other class, of course, the third class that we want to talk about is what we call the open-ended classes. Open-ended classes. We need to understand the open-ended classes. The open-ended classes, these are classes where the lower class limits where the lower class limits and the upper class limits are either not known and either not known. They are either not known, in other words, they are far from the rest of the values, or they may change within time or circumstances. They are either not known because they are too far. They are either too small or too big, or they may change with time or with the circumstances. They are either not known, which implies that they are either not known, i.e., they are too far, from the rest of the values. Of course, in bracket, either they are too small or too big, or they are either not known or they may change with time, or they may change with time. They may change with time or circumstances. So we need maybe to have a look at them. We can have maybe those which are too small. You can have classes that have maybe, let me call them ages, this age, and then the frequency. We can have, you may see values that start with less than maybe 99.5, maybe less than, when you find maybe can put maybe 120. They're just showing these figures like that. Maybe this one we can say 100, maybe 120. But you find that some values here, they are not specified. Then when they come here, they say maybe 300, then they say greater than, when the value here is not given. So it means that the value that can be here can be either too big, then this one can be too small. Then this one, they can give you 2, 3, 4, and those are the frequencies. So you can have such information. Those are the ones that we call open-ended classes. They may not have a starting point and they may not give you an ending point, because some of the values may not be known, may be either too small or they may be too big. So those are the three types of classes that we have: the open-ended, the inclusive, and then the exclusive classes. Of course, we need also to understand other terms that are used other than the classes. We have understood the class limits. We've said the class limits, we have both the lower class limit and then the upper class limits. Of course, those are the upper and then the lower. Let me write it. Let me write the definition. Class limits. Class The other term that we have to understand is what we call the class boundaries. The class boundaries. Class boundaries, of course, these are numbers. These are numbers used to separate the classes, so that there are no gaps, are no there are no gaps in the frequency distribution. So these are numbers that are used to separate classes so that there are no gaps in the frequency distribution. We have what we call the upper class boundary and then the lower class boundary. We have the upper class boundary and then the lower class boundary. The lower class boundary, of course, the upper class boundary is equal to the upper class limit, plus 0.5 times D. I will explain as we go on. Then the lower class boundary, of course, it is now the lower limit plus 0.5 times D, and D is the size of the gap that exists between successive. We have said that D is the size of the gap that exists between successive classes. So that's all that I wanted. To talk about as far as this class is concerned. Let's meet in the next video as we are looking at computations.